So, how is it possible that a 400-year-old law of physics is maybe the single most important thing keeping you safe in your car every single day? Well, the answer is pretty incredible, and it all comes down to one powerful, invisible force. Let's break it down. Okay, first, let's kind of reframe this. A car crash isn't just some random accident. Think of it more like a dramatic, high-speed physics experiment, and your body is caught right in the middle of it. The forces at play are just immense. They're invisible, and they follow a very, very specific set of rules. And look, the stakes here they're incredibly high. In Canada alone, we're talking about 160,000 accidents every single year. I mean, that's a number that's hard to even wrap your head around. And tragically, about 3,000 of those are fatal. So understanding the physics we're about to get into isn't just, a mental exercise. It's what separates a close call from a real tragedy. So this gets us to the big question, right? When your car comes to a sudden, violent stop, what really happens to your body? Now, you probably think you get thrown forward, but the truth is actually much more counterintuitive, and it's all rooted in physics. And it all comes down to this thing I like to call the stubbornness of stuff. It's this deep, fundamental resistance to change that absolutely everything in the universe has. And in physics, this stubbornness has a name: inertia. So inertia, at its core, is basically an object's deep-seated desire to keep doing whatever it's already doing. If it's sitting still, it wants to stay sitting still. If it's moving, it wants to keep on moving. It resists any change. And here's the really important part. The more mass something has, the more inertia it has. Think about it. A huge truck is way more stubborn than, say, a feather. It's much harder to get moving, and it's way, way harder to stop. It has this powerful resistance to any change in its motion. Okay, here's a great example. Picture a little stuffed animal on your dashboard. When you hit the gas and accelerate, the car shoots forward, but that toy's inertia makes it want to stay put. The car literally moves out from under it, making it look like the toy flew backward. But it didn't really fly backward. The car flew forward, right out from under it. For centuries, we had this whole motion thing completely backward. The big idea was that objects are naturally lazy, and you need to constantly push them to keep them going. And then, back in the 1600s, this guy named Galileo comes along and just flips the whole idea on its head. Right, so the old way of thinking was that you needed to constantly push something to keep it moving. But Galileo's insight was revolutionary. It was the total opposite. An object in motion will stay in motion at a constant speed pretty much forever, unless an outside force, something like friction, acts on it. Galileo came up with this brilliant thought experiment to prove his point. Imagine a ball rolling down a ramp and then up another one. It'll always try to get back to its original height. Okay, now if you make that second ramp less steep, the ball has to travel farther to get back up, right? So what happens if there's no second ramp at all? Well, the ball would just keep rolling forever, because it's always trying to reach a height it can never get to. So Galileo gave us this amazing concept of inertia. But it took another genius, Sir Isaac Newton, to take that idea and really turn it into a solid, ironclad law of the universe. And get this. Here's a really cool little fact of scientific history. The very same year that Galileo died, 1642, Isaac Newton was born. It's almost like a scientific torch was being passed from one generation to the next. Decades later, Newton published his massive work, Principia Mathematica, and inside, he gave us his first law of motion. And here it is, the law itself, in all its elegant simplicity. What does that really mean? Well, basically, stuff just keeps on doing what it's already doing unless something from the outside comes and messes with it. No external force, no change in motion. It's that simple, and it's that profound. The implications here are they're huge. It means that coasting, just moving along, that's the natural state of things, not stopping. You only need to apply a force when you want to change something, to speed up, to slow down, or to change direction. Okay, so we've got this powerful universal law, but how in the world do we get from there back to that car crash? This is where abstract physics becomes life-saving engineering. So the real question for engineers is, how do you outsmart inertia? I mean, if your body is just going to stubbornly keep moving forward in a crash, how do you design something to stop it safely? All right, let's take a rear-end collision first. The car is suddenly slammed forward, and the seat pushes your body right along with it. But your head, because of its own inertia, resists that change. It lags behind for just a split second, causing your neck to snap back violently. and boom, that's whiplash. So, the solution? It's a piece of engineering genius, and it's based directly on Newton's law. That headrest, it's not really there for comfort. It's specifically designed to apply an external force to your head at the exact same moment the seat pushes your body, so they move forward together. And that prevents that dangerous snap.
And a seatbelt? It's the exact same idea, just for a head-on crash. Your car stops dead, but your body's inertia wants to keep right on going at, 60 miles an hour. That seatbelt, that is the external force that grabs you and slows you down safely with the frame of the car, instead of letting the dashboard do it.
So, the bottom line is this fundamental law isn't just in textbooks. It's at work all around you, all the time. It's why the coffee sloshes in your cup when you accelerate, and it's why an astronaut has to be tethered in space. So, now that you know what to look for, where are you going to see this stubbornness of stuff in action next?